So what we did was we worked out a way of fitting as many chemicals as possible into there so that we could still fit things like test tube holders, spatulas into the box. We put all of these into here so that it could remain neat. We made everything homemade that we could. Unfortunately, we couldn't think of anything for a spatula or test tube holders that we could make ourselves. But the Bunsen's one of the best. The tripod is one of the best examples we've got of something we've made ourselves, as it collapses so that it'll fit down tightly into the box. Now I'll pass on to Chris, who's going to make some glass.
Right, I'm going to make some glass which consists of lead oxide, boric acid, zinc oxide and iron oxide. I've put measured amounts into this jar here, and I'm going to crush them up into the water. I'm going to crush them up to make a fine colour. And then I'm going to put them into here, which I'll melt till they turn into a liquid. Once they are a liquid, I will then pour them into this glass of water, which will then splinter them into fine beads. I'm going to dry them off and put them and crush them up. Then put them onto this mould here and heat them up so it'll make some glass. While I'm doing that, Paul's going to do some other small experiments.
What I've done so far is to make some copper sulphate solution. And I'm going to add to this some iron filings to find out which is more reactive, iron filings or copper sulphate. After I've made the copper sulphate solution, I add a small amount of iron filings. Into the test tube. Gently shake it up. Instantly, the iron filings begin to go copper coloured, which proves that they are more reactive than the copper sulphate. And to prove this further, the colour of the water has changed from being blue, and it's gradually going back to being clear. If we leave this for a while, it will eventually go back to being fully clear, and there won't be a trace of blue in it. Now I'm going to form some magnesium oxide. First of all, I have to make some universal indicator solution. I don't need too much water, because I don't want to make too much. The water's gone off again. Right, so I only have to make a small amount of this. So I put about a third of a test tube full. Now to this, I'll add a few drops of universal indicator. Don't need much, just a few drops will do. Well, what should have happened is that should have gone to about pH 7, which is a neutral colour, but unfortunately it's gone acid. I'm not sure why, it must be something on the right, we should still be able to prove whether it's alkaline or not by just if it goes up to be more orange or yellow, then obviously the magnesium will be an alkaline. So now, let's move this down. And I'll burn some magnesium. Once it's finished burning, drop it into there, and then if it moves up the scale, then it's alkaline. But if it stays the same, then it's either neutral or acidic. Unfortunately, due to the fact the universal indicator giving off an acid colour straight away, so it can't work fully. some magnesium in the bunsen. I have to put it on a blue flame so magnesium doesn't burn in the yellow flame. Now, once it starts to burn, I'll leave it until it's finished burning. Now I'll drop it into the universal indicator solution. Now I'll shake it up. It's changed the universal indicator solution to slightly less red colour, which means that it is an alkaline.
Powder's now melted into a liquid, which I'm now going to pour into the water. Now I'm going to drain off the excess water.
I'm going to do some chromatography now. Fortunately, I can't clean this properly. In fact, I've got no water in the tank. I'll have to let it get into the... and I don't want to let it get into this water, which is the only water we've got.
When you got your gas well, and Jim has got his water.
Right, there we are. Right. So now we've got it clean. Now I'll add some water into this. It's the empty container. Right now, I just put a small amount of water into here, and I get out the chromatography paper. This will show what sort of dye is going to making black ink which goes into a pen. First of all, I have to make sure that when I draw a line around the chromatography paper, it'll be high enough up so that the ink won't actually go into the water. I'll do this by measuring it out and just making a small mark so I know how high to put it. Now I draw a line right round it, straight as possible. Also do the other side. Now I put a fold in the paper so that it won't touch the side of the holder, and it should just stand up in the middle. So now I put it into there. And now, if we leave it for a while, then all of the inks will separate out, and we'll be able to see all of the different dyes that have gone in to make this colour.
I've interrupted again. I'm now going to crush, I've dried the glass off, I'm now going to crush it into a powder, which now will melt onto here to form a small piece of glass.
Now, as you can see, all the colours are beginning to separate out, and at the moment, I can see that there's purple gone into making it. There's also a small amount of green, but the longer we leave that, the further up the paper it will come, and the more you'll be able to see the different colours. Now, I'm going to see what the effect is from heating zinc oxide. Put a small amount of this into a test tube. Now, I'll just put a small amount of this into the test tube. Now I'll heat this up. What should happen is that the electrons will start moving about and it should change colour. This does not actually affect the powder. It's when I take it out again and it cools back down, it'll go back to being white again. So I heat it on a yellow, on a blue flame, so that the test tube does not go sooty. I'll heat this up, and straight away begins to go yellow. It also starts to give us smoke.
While it's starting to melt now, it's starting to form a roll of gas. I think some light in water now.
Now the powder is just starting to go yellow colour now. There, now it's fully changed. It's gone yellow. So now if I leave that, it'll go back to being white and it will not actually affected it at all. Just when it cools down, I'll be able to use it again for any other experiment I wish to do. And it won't affect the experiment in any way. This is still in the same form as before. So heating doesn't affect it, as it will always cool down back to its original form. It's beginning to go back to white now. Right. From the first experiment we did, which was the copper and adding the iron to it, the blue's almost completely gone out of it now, which has proved that the iron is more reactive than the copper.
I'm just going to turn the glass over because the powder inside has melted.
Now I'm going to make some soap. First of all, it requires me to make a saturated salt solution. You need about 25 millilitres of water in the beaker. Now this I add some sodium chloride. I've got to add enough. I've got to add plenty until it reaches saturation point. I'll stir this up, and if all of it dissolves, then I'll have to add some more, and I keep doing this until no more will dissolve in it, and that means it's a saturated solution. All that's dissolved, so I'll add a bit more. You've got to take it slowly. You don't want too much over the limit. You don't want much salt resting on the bottom, or that will spoil the experiment. There we are. All of that hasn't dissolved, so that's a saturated solution of salt now.
Just waiting for the glass to cool down now.
Right, so now I get out the cooking oil, which is just ordinary cooking oil. You could use lard, any form of fat. I'll put some of this into the test tube. I don't need too much of this, because I'll have to heat it and I don't want it to take too long to heat. You would have to take about 15 minutes overheating this. Unfortunately, we don't quite have that long.
Now from a piece of glass, which I don't think people back there will see. It's small. You meant to do that.
Right, so to this, I have a sodium hydroxide pellet, which I have to be careful with because they're caustic, so I've got to let it touch my hand. Also, when I reseal this afterwards, I have to make sure that they get sealed properly because they're taking the moisture from the air and it ruins them.